Hello, my name is Goran and this video is about my mega fave number in response to James Grime and other mathematicians presenting a challenge to create a video about an interesting number larger than 1 million. I have chosen 1,413,214.562373095048 and so on. You may realise that this is root 2 multiplied by 1 million, and to explain why I chose it, we have to go back a few years. It started when I was eating a samosa and I considered what ways you could cut it in half. And the easiest way would be to just go down the middle, like this, or perpendicularly to the base. But then I thought, what if I wanted to cut horizontally? And now the question becomes, how far along this edge do I have to start cutting for the area of this triangle and this trapezium to be the same? So to begin, we'll take an arbitrary triangle, like so. Oh, ignore the curve. Okay, so we will label this angle alpha, that's beta, that can be gamma, okay, and then we've got, we'll call this small length A, this small length B, this one C, and then this larger one here is X, Y is that side, and Z is here. So first we'll work out the area of the small triangle, which is given by half AB sine C. Okay, so that's for a triangle that looks like this. Okay, if that's angle C there, then this is A and this is B. Okay, so in our case, this area is half A times C. Now because this small triangle and the large one are similar, we can actually use the similar triangles, and so we know that this angle here is also alpha. Okay, so that's the area of the small triangle. Now for the area of the trapezium. Okay, so the formula for an area of a trapezium is half of A plus B times H. Now H is the vertical height here. Okay, so we need to do a bit of trigonometry to work that out for our one. Okay, so if I put a dotted line here, that is H. Well, we can bring that over here. Okay, and so this angle, alpha, this angle is this length is H, and then this length is X minus A. Okay, now trigonometry tells us that sine of alpha equals opposite, which is H, over the hypotenuse, which is X minus A. So H equals X minus A times sine of alpha. Now we can plug these into the formula for this trapezium. Okay, and we get that area of the trapezium equals half C plus Z, are A and B in this case, and then times X minus A sine alpha. Okay, now we can equate these two areas, so area of the triangle equals area of the trapezium. Okay, so half AC sine alpha equals half C plus Z x minus A sine alpha. Okay, we can cancel the halves, and we can also cancel the sine alphas because alpha, beta, and gamma are all between 0 and 180 degrees. So sine of those angles will never be 0, so we can cancel them. Okay, and we are left with AC equals C plus Z times x minus a, which I think is pretty cool that you've got this formula relating just the lengths of the triangle. Okay, now what we want is a ratio between x and a, so we need to get rid of, okay, c and z. So the sine rule tells us that c over a, these lengths, is equal to the ratio between sine of beta over sine of gamma, and similarly z over x is equal to sine beta over sine gamma as well. Pardon me. Okay, so we can plug so then this one tells us that C equals hang on, that's not going to work. So we can plug these in for C and Z, okay, and we get that A squared sine beta over sine of gamma equals A sine beta over sine gamma plus x sine beta over sine gamma, all of that in brackets, and then that multiplied by x minus a. Okay, and then I think we will need new paper. So then again we can cancel out the sine beta over sine of gamma, because beta and gamma are between 0 and 180, so sine of them is never 0. Okay, and we are left with a squared equals a plus x times x minus a. Okay, we can expand the brackets, get a squared equals x squared minus a squared. Okay, rearrange, group all like terms, and we get that a is equal to 1 over root 2 times x. So the ratio between the long length and the short length, okay, is 1 over root 2, which I think is pretty cool. You know, like the root 2 just comes out, you know, I don't know why exactly, other than it's the square root of a half, so I guess that makes some sense. But to make it my megafave number, I considered what length of x would I need so that a is 1 million, and so that is 1,000,000 times root 2, which is my megafave number. Thank you.